All right. Hello, Professor. This will be going over the CPU at a high-ish level. Um, yeah. So let's first start at the clock. So the clock is just a pulse, and it ticks up and down. On each positive edge of the clock, the program counter, because it's an FSM that's full of flip-flops, will increment by 1. And so from the program counter, we then go into a decoder, which will take the it'll take the 3-bit value that we have for the program counter, and it'll change that into 8 bits. Um, and on each bit, except for one of them, it'll be 0, and the other will be 5 volts. And here we have the ROM. And so it'll take in the decoded message and it'll spit out the appropriate instruction based on whatever the program counter is at. And once we have the instruction, we have all of our control bits. Great. So once we have our control bits, we can just start going through the circuit. And the best way to do that is with instructions. So the first instruction is going to be a load instruction. And so a couple important things from the instructions that are set when we have a load instruction is we get the SRAM address. We're going to have memWrite set to low. We're also going to get to choose which register we want to write to from the SRAM. We're going to enable write. And yeah. And so the SRAM address will choose which address to spit out onto this bit line. And then we also have the data select line, which is going to allow the SRAM instead of the ALU value to go through into the register. Here we have another decoder that's going to choose which register we want to write to. And so say we're writing to register 0. And since write is high and the register 0 bit is high, it's going to get passed through there. And then here we're gating the clock. So this essentially only says when write is high and we have selected this register, let the clock through. Otherwise, don't let the clock through. And so then once the clock is high, or once we get a positive edge of the clock, the register, register 0, which is just another flip-flop, is going, or another set of 8 flip-flops, is going to take in what's on the input, and it's going to fill up the register. And that's the load instruction. The next instruction is going to be the add instruction. On the add instruction, we're going to choose again. We're going to choose which registers we want to do the math with. So that's select A and select B. Those come from the instructions. And so those will get passed through here. Oh, well, one of them will get passed through there. The other is going to get passed through here. This is go up to the add. This is a combinational logic block that will do our addition. It's going to get passed to this mux here. Our ALU select bit is going to go low from the instruction, and it's going to let the result of the summation go through rather than the result of the product. And then this, the summation is going to go over here. The data select is going to choose the result of the ALU versus the SRAM, and it's going to let that through. And so now we have the result of the summation of the register we chose from select A and the register we chose from select B, and we have that on the inline. And then since we're also selecting the register to write to, let's just say it's register 3. So write is going to go high, and we decoded it, and so that's going to let the clock through here. And so then on the positive edge of the clock, the result of the ALU is going to get loaded into into the third register. All right, now for multiplication, it's essentially going to be the same thing, except what's going to happen here. So again, both of these combinational logic locks are going to do the math, and they're both going to come out here. But now our ALU select is going to choose the result of the multiply rather than the results of the summation. And so we're going to pass that through again. We're going to pass that through here to the data select. And then on the positive edge of the clock, the register that we have selected, let's say this one, will be the only one where the clock is allowed to go through, and that register will then be updated to the value that was the result of the multiplication. And then the final instruction is going to be a store instruction. And so store instruction is storing a register into the SRAM. And so for that, we're going to need the SRAM address that we want to write to, and we're going to want to set memWrite to high to allow us to write to the SRAM. Then we're also going to select which register to save into the SRAM. And so that's going to come from the instructions. And so we take it directly out from here. And then we're going to choose the register to, that's going to get passed through. And SRAM is going to be updated to the value of the register. And yeah, that is all the instructions.